All right, this is Learning Target 3 for Unit 1 on energy, on potential energy. So potential energy is, I'm going to put this up here, mass times the gravity times the height. So you need to know that position makes a difference. So if I pull this up, notice that the bar on the left is increasing as I pull it up. So if I pull it up higher, the bar goes higher. If I pull it lower, the bar goes lower. So this helps us understand what potential energy is. Potential energy is based on height. So we have right here, we can increase the mass. I can show you that mass, if it's smaller, then it doesn't get as big as mass that's bigger. The gravity system that we have here is a lower gravity system. If I increase the gravity system, it has more height and it will fall faster than if the gravity system is lower. So, most important takeaway is what potential energy is. It's energy based on height. So if I have potential energy here, it's going to give this much on this side, and it's going to turn into kinetic and go back to potential. So it always changes forms. Right now we have no friction, so nothing's going to heat. If I turn on friction, it's going to slowly gain heat, and as it slowly gains heat, it will start to slow down even more. So going back, let's say I'm going to pause this and we're going to make it go higher. Up here, would I have more or less potential? And the answer is I would have more potential energy. So this would be more potential energy. And we can assume that if you have more potential energy, it's going to cause more kinetic energy. So as we push play, we have more potential is causing more kinetic. If I bring it down with less potential, it would cause less kinetic, and you can see it here on the side. You'll notice that energy is always going to be conserved. Energy has to go somewhere. If there's no friction, all of the kinetic energy will become potential energy. So if I place it up here with the most potential, all of that potential energy will become kinetic energy, and it changes forms back and forth. So that's with no friction present. But we live in a world where we have friction. So once I add friction up, notice that what's going to happen is we're going to slowly start gaining heat. So each fall is just not going to be quite as tall as the next one because it's slowly becoming heat friction. So that's the main takeaway from this lesson. More potential energy causes more kinetic. Less potential energy causes less kinetic. Energy is conserved, meaning it must go somewhere. No friction, all the potential will become kinetic, and vice versa. If you have friction, it's slowly going to turn some of that kinetic energy into heat through air friction, and it will lower the potential energy over time. So on Earth, in a friction system, we do not have anything lasting forever. Everything is going to slow down and come to a stop. And that's it.